All right, this is lesson 139. We're going to be talking about comparing triangles. We need to know why triangles are the same because we want to be able to compare things in real life and do it logically. So logic, remember, all San Dimas students are awesome. Brian is a San Dimas student, therefore. Okay, good. Awesome, cool. And we want to sound logical. I know as students we're learning, and I wouldn't ever make you feel bad for not knowing or being logical. I'll help you try to be as logical as you can. But when you become an adult and you sound illogical, do you think people are going to be nice to you? No. Right? So, you know, the logic we learn in math supports that. We want to sound logical. And we want to be able to compare shapes and make sure that they logically look the same, okay? Otherwise, you know, you might not look like you know what you're doing. We don't want that. All right, so one of the things that, or these are a couple of vocabulary terms, corresponding parts of congruent triangles are congruent. So we can make an assumption, a logical conclusion that corresponding parts of congruent triangles are congruent. And then there's this other thing called the biconditional statement, which says like P will only happen if and only if Q happens, okay? So here's an example. Let's say your parents tell you, I'll take you to Disneyland if and only if you have only A's and B's on in your final report card. Okay? Well, are they guaranteed to take you to Disneyland? No. When would they take you to Disneyland?
If A's and B's.
If and only if you have A's and B's on your final report card. Does that make sense?
Yes.
Cool. Okay.
What if you have one C?
So that's a good question. What if you have 1C? Would your parents take you? No, because they would only take you if and only if you have A's and B's. Okay? They do, but would they take you to Disneyland if your parents say if and only if? Right? Okay. And you always want to shoot for the highest grade, of course. All right, here we go. Okay, I'm going to do a couple problems up here. It's not a very hard concept. Not a very hard concept, but you definitely want to go slow. You want to annotate things as you go. So, you know, on your paper or on your AMs or on a test, you definitely would want to annotate the drawing or make sure it makes sense. Tommy, warning. Thank you. Okay, so we have our KLM, triangle KLM, and we got triangle QRS, okay? When I look at these two triangles, what transformation just occurred for both of them? Talk to me really quick. 5 seconds. Okay, reflection. Okay, good. So I want to make sure that things are lining up. Okay, so I noticed that. First thing I notice is that the sides, they put dash marks for me. They don't do that on all my problems, right? But they're saying, hey, look at the hypotenuse of this first triangle here. The first triangle, it says that this hypotenuse is the same as this hypotenuse, so we could assume that they're the same length. And then it also says the side KL is the same length as the side as QR, right? These two sides are the same. And it also says that side LM is the same as side RS, okay? So that's good. All the sides are the same. So I'm also going to check my angles, okay? So looking at my first angle, so let's look at the angle 57. I notice angle 57 is between the side that has the single dash, right, and this double dash right here. So, and it's also present here on the second triangle, so that's good, okay? Then I'm looking at this angle 91. This one's also the same and present and in the same location, in the corresponding location. And then angle 32 is the same, okay? So can we make a fair assumption that these two triangles are congruent?
Yes.
Yeah, they're two separate triangles. They're two different triangles, but they are congruent, meaning they have the same shape and corresponding sides and angles. So then I can make this statement. I could say that triangle KLM is congruent to triangle QRS, okay? So I can make this assumption logically, right? Do I sound illogical by saying that?
No.
No, okay, good. And then I could also make some other logical statements. Which angle is congruent to angle K, everyone?
Angle Q.
Good, angle Q. So I could write that. That's a fair statement. What about what angle is congruent to angle L?
Angle R.
R, okay, good. Everyone, what angle is congruent to angle M? Okay, good. Angle S, right? And we could do that with sides too. Let's look at line segment KL. What line segment is congruent to line segment KL?
QR.
Cool. Line segment QR. That's right. And what line segment is congruent to line segment LM? Okay, and what line segment is congruent to line segment MK
QS.
or SQ? It doesn't matter what order, as long as you put the line segment above, okay? Okay, does that make sense on number 1? Okay, cool. Number 2, eyes up here, okay? Number 2, turn your neighbors and tell them what transformations are happening from the original pre-image to the image here. Okay, what transformations are happening, everyone? Rotation, that's correct, okay? Now, this one, we're going to do the same thing. It doesn't give us dashes, okay? But I noticed that it says, hey, look, it says 7 inches on both of these, right? So I could put dash marks. You see that? Can't I assume these two sides are the same? Okay, Braden, warning. Can I assume that these two sides are the same? Okay, good. Now I can keep going here. Are there any other sides I could assume are the same? Not yet. No, I can't. Okay? Unless they gave me measurements, I can't. So now let's look at the angles. Maybe the angles could help support that that this is congruent. So notice it says 35 here and 35 on the other one. So I could say that these two are congruent. Okay? Then I notice that 63 is here, right? And then I say 65 is there. Aren't those close enough? Can't I say that they're exactly the same? No, are they? Can I say they're congruent? No. Uh-oh, so that makes a problem, right? So these are not congruent. So since they're not the same, we can't say they're congruent. So we'd say triangle RST is not congruent to triangle UVW. Okay? Does that make sense, everyone?
Yeah.
So can I make any of these statements on the second triangle? No. The only statement I can make is that angle TRS is congruent to angle VUW, and I could say that side RS is congruent to side UV. Okay? That's all I could say. All right, so let's have some math chatting. Today is Thursday. Let's start with the 4s today, 4, 4, 4. There's no 4 in the back group, so Jonathan, you will be the 4 there. All my 4s in the house, you will explain how you could tell if things are congruent based upon these two examples, okay? Or triangles are congruent. Ready, set, and go. Number 3, okay? So number 3, oh, there's your answer right there. My bad. Went a little too fast there. Okay. Okay, so on number 3, turn to neighbors, discuss. Are these congruent, yes or no? Yes. Okay, why? So let's do this together. I notice there is a single dash here and a single dash here, and that there's a 50-degree angle on this one, 69-degree angle here, right? So this whole side's the same, right? And I notice there's a double dash here and a double dash here, and there's a triple dash here and triple dash here, meaning they are the same, right? So what's the measure of this last angle? It doesn't give us a last angle, like this one and this one. Are these angles the same?
Yes.
Okay, we don't know that yet. So I want to let you know that, or let's see if you remember this. How many degrees do all of the interior angles of a triangle add up to, everyone?
180.
180, right? So what's this last angle then?
61 degrees.
61, right? What about this last angle? How many degrees is it?
61.
61, right? So then I could assume, after calculating them, that this one's 61 and the other one's 61. So, do these triangles look congruent?
Yes.
Yep, we could assume they're congruent. Can we assume all of the sides and angles are congruent?
Yes.
Good. Does that make sense?
Yes.
Okay, cool. Let's keep going. Next one you're going to do with your group, and then we're going to discuss as a class, okay? Okay. Are these two triangles congruent? Yes or no? Talk to your groups. Okay? Ready, set, and talk.